So in the previous workshop, we have actually covered like how to bootstrap a new COSM WASM contract, as well as we have seen like how different entry points actually look like and how to write queries as well as transaction. So now once we are actually able to write all the transaction query as well as the test cases, we will proceed to first build our project and then see how chain interaction with this contract actually works. So as we have seen previously, like once we have run all our test cases, let it be cargo test. Okay, we had changed one value from 17 to 18, you must be remembering. So those who have not seen the previous workshop, I would recommend them to actually go through it so that they can get a context of how the interaction of chain can work thereafter. So once we have fixed it, let's run cargo test. So we have successfully passed all our test cases. So now is the time to first compile our code. So to do that, we will actually use cargo wasm that will be running all the checks on our system and creating an optimized build. Once we are done with this, our second aim is to create a wasm file or a wasm binary. To do that, we actually need Rust optimizer, which can actually optimize your wasm code. Like you can actually upload your wasm file, which will not be optimized as well. But the main intention of using an optimized wasm file is to reduce the gas utilization. So if there's less gas utilization, then you will obviously be paying less fees, and every transaction or query or even the uploaded part will be occupying less space. So that's the main reason we'll be using the Rust optimizer. So in order to actually use the Rust optimizer, you need to have the prerequisite of Docker installed in your particular system to able to optimize your smart contract. So I have already Docker installed in my system, which is running right now. So in the cargo terminal file, we actually have the optimizer command, which you can actually copy. So I'll just copy this and run this. So it takes a while to create the build for that. Let's wait for a couple of minutes until it's done. Copy this and run this. To know more about like Rust optimizer, you can anyway go to wasm GitHub. Go to their main repository organization and opt Rust optimizers. So from here also, like you can just copy the command based on the versions you are using. Currently, for the prior versions, we are actually using 0.12.6. For different versions, you can just find different optimizer that works upon it. So here you can actually see all the tags or all the versions that are currently we are using. So right now we are using this one, and based on a different Cosm wasm or the Cosmos SDK version, Cosm wasm STT version you are using. Based on that, you can like tweak your own optimizer version. So yes, we have successfully completed our optimization, and you will find the final wasm file in this artifacts folder, where you can see the workshop2.wasm file, as well as you will get a checksum. So checksum is always to validate whether you have compiled the correct code or not. Every time I'll just compile this code, I'll get the same checksum. But if I make a slight change in the contract, this will completely give me a new checksum. So it's always good to just check whether your compiled code actually matches with the checksum or not. So now we are good with our wasm file. So our next step will be actually to interact with our testnet, where we'll first be uploading this contract and creating a new instance with it. So let's start over it. So we'll just create a new tab. So our command will be comdex tx wasm. To reiterate, Comdex TX wasm actually means that in the Comdex binary, you are actually doing a transaction in the wasm module, and which is then followed by a function that you are actually specifically calling in a wasm module. So let's check what are the different commands that we have right now. So let it be like minus minus help will let me know all the commands that we require. So it's currently write, store, instantiate, execute, migrate, and set contract admin, and more of the different functionalities are there, which we actually talked a bit about it in the last, or I guess in the last video. So first we are going to store the command, or like store our wasm file in the blockchain. So the command will be comdex tx wasm store, and you can just write minus myself to let you know what are the arguments it actually require you for you. So you can see that it actually requires a wasm file, and there are a few flags, and these are the flags that you actually require. So you guys can go through it and get to know more about the details of each flag, but for simplicity now we will just be uploading it right now. So and we'll pointing to our RPC node of our NovaNet test chain. So let's go to our NovaNet test chain. So in the hackathon details that we have in our Dora Hacks page, you will actually see this Comdex NovaNet chain details, which is very required to interact with our testnet chain. So Comdex, let's clear it up first. Now Comdex tx wasm, and the location of my folder. So let's be dot slash rt facts slash workshop 2 dot wasm, and then I'll just provide the different arguments as well, flags. So the first will be obviously like the my wallet. So in the previous example, like I had already created a wallet named temp1, so we'll be using that only. So it will be minus minus from temp1, and then I need to provide the chain ID. So chain ID, you can just fetch it from the chain details, which is Comdex NovaNet, and we'll just paste it here. Now the next argument we'll require is minus minus node, which is our RPC node. Will copy just it from here and just paste it. So now we have just provided our from chain ID NovaNet. We'll just provide some gas as well as some fees. We'll just pay some gas as well as let's provide some fees. Let the fees be like, okay, this much UCMDX, and let's hit enter. Unknown command. Okay, sorry, I just missed to add store. Yep. So let's just execute it. And this, we have not already provided minus y, which is actually by default signing in broadcasting a transaction on its own. So we'll just confirm it here, and it will be y. And here you will see a transaction has given to you. So basically with this transaction as you can retrieve what is the code ID that you have actually uploaded. So we can actually go to a block explorer and see how it can be seen. So let's go to a block explorer, and in the cell section let's paste our transaction hash. You can see this is the wasm bytecode that we have uploaded through our message, basically message store code. And here you will see the in the store code we have actually received our code ID into with which in the basically logs file or in the logs response. So currently we have actually uploaded our code, and our code ID is 2. This is the code ID that we are actually going to use to create an instance of our code. So let's see how to create an instantiation. So to actually create an instantiation, let's actually look at how our instantiation message actually looked like. So once we actually go to our messages, we see that instantiation messages only takes count, and based on the count it can actually create a instance. So let's do it this way. So first what we'll do is we'll create a instantiation message. So let's see how instantiation messages and what are the parameters. So we'll just do comdex tx wasm. So we'll just copy instantiate, and we'll just do minus minus help to let's know what are the arguments it actually needs. So you can see arguments it actually requires is a code ID. So from this previous transition, we know that our code ID is 2, and the JSON encoded initial arguments which is required, and also a label. Label is something that will actually provide a kind of a label to your contract instance, not a code ID, rather it will be on your instance of the code. And admin, which is something is an optional field. I would request everyone to provide some address to your contract instance, because once you are actually trying to create a new code and point your instance to that new code, this particular admin that you had set can only be able to do that. So admin, though it's given optional, but I would strongly recommend you to just provide some admin address to it. And even amount is optional, so you can consider amount is like something like a payable that you have in Solidity, where you just need to pay some tokens in order for your transaction to run. So in that particular sense, you are actually paying this tokens, and this tokens will actually be going to your smart contract address that you will be actually creating on it. So you can basically, with this command, basically you can bootstrap your contract instance with some funds logged in that particular contract address. So let's do the instantiation. So our code was 2, and let's create a JSON. So our JSON should be like inverted commas. It asked for a count. So see, in our instantiation message, it was just a count, which was an integer 32. So let's make it like count, and value should be, let's say, 1. Uh, okay, we'll just close it. And the next set of arguments that we actually require is a label. So let's make a label as minus minus label, and in this label we'll just provide let's say my first instance. And so I provided my first instance, then what was the next argument, which was minus minus admin and the address. So minus minus admin will be my own address. So let's check my own address. So I can just check it by Comdex keys list. Just a second. Just a second. Or I'll just copy the second thing. Comdex keys list minus minus key ring again test. So let's take some other address, which can be the admin of this particular address. So let's make it, where was my transaction? So let the address be this one. And then what was our different other arguments? So amount, we will not be actually providing some amount to this particular instantiation function, which it doesn't even require. So now will be minus minus from, which will be temp1, and then yeah, then we need to provide all the required details, that what was the chain ID. So we'll actually copy it from the previous transactions we did. So we'll just go a bit above. We'll copy all the chain details and the fee details over here. And we'll just, well, now we can just copy this transaction hash and paste it in our Explorer. So where's the Explorer? Yeah, yeah, okay. So we'll just paste it in the Explorer and just hit enter. So you'll see our message was to instantiate a code ID of 2 with the label of my first instance. And here you will see in the logs, we'll get a contract address associated with a code ID 2, which you can see here. You can also query the same in the CLI as well. So I'll just create these tabs. I'll create a new, and let's name it as a query part, where we'll use this to just query everything. Query. So we'll just use Comdex Q wasm, and let's provide minus minus node, and our node ID is this. So you'll see all the commands that are actually available there. So by using list code, you can actually go through how many codes have been uploaded to this chain. So you can just copy list code, paste it over here. It will tell you that currently there have been 2 codes currently uploaded there with their creator, and this is the permission that have been there for instantiation. So by default, once you have actually uploaded your code, by default the permission of instantiation is everybody. So what I mean by this is, whenever you are trying, like, anyone can actually create an instance of your code, given that he provides the correct parameters for it. To actually avoid it, we actually have instance only address or instance only main nobody, so that you can restrict people for instantiating your code address, basically code ID. So basically this query actually helps us to know, like, what are the different code IDs that is, and it's basically an incremental process where every code ID will be given a ID which is incremented by 1 from the previous code ID. So the next command is list contract by code. So let's see if we have some instance associated within a code ID or not. So let's copy list contract by code, and let's provide code ID 2. So you can see that we actually have an instance right now associated with a code ID 2, and this is the same instance we have seen in this previous Explorer, where we have actually get ZSW, and this is even ZSW. So our contract instance is ready right now. So the next thing that we actually have to do is try to interact with it and try to query the states right now. So you must be remembering that what this particular contract does. So it basically increments your contract by 1 every time you call this one increment function. So let's try to do that. So you can see that the execution messages has 2 variants. One is increment, one is reset, and we can query messages by get count. So since we are done with executions, so since we are done with instantiation, let's go to execution part, where we can see that what is the current query. So for that, let's check that what is the since we have actually uploaded instance with data 1 or 0, I think. Let's check it. So in the previous transaction, we have a core ID of 2 and our instance was successful. As we can see, store code was done and instantiation. This is for store code. Just a second. Yeah. So this is done. So now what we'll actually do is let's try to query that what is the current count. So whatever we actually provided in our instantiation message will be our query count. So let's go with it. So the query will be same. Comdex q wasm, and then when you go to wasm, you will see there's a command called contract state. So we'll just write command state, and then we actually have to let's check minus minus help of what it actually requires. So it asks for all raw or smart. So let's go with smart, where we'll just provide the query JSON and get our data. So now it requires address and a query. So address, you must be knowing, will be the contract address that you have actually generated, and the query is the query that or a query variant that you are actually trying to query from that particular instance. So we know that contract address was this, or we have our contract address there. Let's check it here. So we have this contract address. Let's just, for time being, let's just comment it here. So we'll just copy this command. We'll just first paste the contract address and the query. So query is get count. So in order to create a message out of your enumerator, always remember that all the variants are actually converted to the snake case. So do remember to convert your queries JSON to snake case for all the variants that you can see in your query. So we'll just create a new JSON string. In the JSON string, our core query is get count. So it will be GT small. And since C is in front of, there's a capital C, so we'll be using underscore for a camel case, and then COUNT count, followed by inverted commas, and then there's nothing. Okay, so this is our message, or basically this is our query, and this is our node. So you will see this, that our query has provided a response count of 1, which we actually used as an instantiation message. So currently our state has the counter variable of 1. And let's remember it, because now we'll be hitting the transaction and we'll be coming back to check like whether this state has changed or not. So let's create one new tab for transaction. Let it be TX. So now we have basically two variants of increment and reset. So let's do the increment right now. So in order to do the increment or to hit the transaction, your command will be comdex tx wasm. And in the wasm, you'll see there's a part called execute, which you will be using to execute a particular instance of a code. So this is execute, and let's check what all argument it requires. So we can see, I'll just so first it requires is a contract address, and the second is the JSON argument for execution. So it is something kind of similar to query, where you actually need to provide the contract address and the query that you are actually trying to point. The only difference is how you are using Q and TX to actually point to your commands. So let's do comdex tx execute. Then our contract address will just copy. We have hard coded over here. And let's create a JSON message. So our JSON message will be execute, but do remember that still you need to use the snake case when you are actually trying to create your encoded JSON message. So this will be increment and then since there's empty parameters, so will not provide any parameters as such. And then we just require to have all the different arguments that we actually have for any messages. So we'll just provide our from address, chain ID, node, gas, etc. And we'll hit this transaction. So let's check of what actually happened in this particular transaction. So we'll just paste our transaction hash here, and you can see that the message it called was increment. Funds is currently empty because we haven't provided any funds in our minus minus amount parameters. So we haven't actually sent any amount of tokens in that particular contract address right now. And you can see these are the raw logs where in the was a module we have used the center was this, which is my temp1 address, as well as we have interacted with this contract address. And yeah, like there are different information that you can see here, whether it's how much gas was wanted, how much gas was used, timestamp of the execution of the message, and basically the encoded value of your key attributes. So these are the main components in your transactions. So now our next aim will be to just check whether the state has changed or not. So we'll just query the same thing of getting the count. So you will just see that yes, our counter variable has actually changed to 2. So this way you can basically interact with any contract. And also one more thing to remember is we actually have a schema file over here. So you will see in the examples, we have a schema.rs file, and schema.rs file can create schemas for all the messages that actually you require in your contracts. You just need to import those, you can say the enumerators that you want to create a schema of. And once you've actually imported it, so for example, I want to create a schema of the count response, the execution enumerators, or the instantiation enumerator, or the query enumerator. So for that, I'll just hit the command cargo schema, and it will actually create a schema of of all the enumerators or messages or the structs that actually I have. So you once you go to the schema part, you will see the JSON encoded messages for all the schemas that you wanted to create. So say for example, we have used say for example query message. So query actually requires one off, and since basically it was an enumerator, so it will be having basically a kind of a one-off flag where you can either get count or some other parameters had there been any other parameter. So currently we have a get count, and get count doesn't require any more fields, so that's why you will not see any more fields out there. uh, for instance, we know that execution message has two variants. So let's go and see how it actually looked. So in the execute message, we have one of a variant of increment, and we know that increment didn't require any arguments as such. And the second one was reset, which actually required an argument. So you can see in the properties of reset, it actually requires an argument. An argument has a type of value integer 32. So that's kind of an example of how you can actually go through the schema and create our own JSON messages once you are creating any transactions or queries. So this was it for this workshop, and from the next workshop we will be concentrating on creating our own contracts on NFT marketplace, right from creating the architecture, defining the schema, as well as writing queries and test cases, and straight to deployment. And so once we are good with the deployment, we will also see like how UI interaction can actually take place via Cosm.js.